Live from Sapphire Now, 2013, Orlando. I'm Carolyn Fitton from SAP here on the mobile showcase floor, and I'm in the Internet of Things booth with Benjamin Wesson, VP of Product Management. How are you today, Benjamin?
I'm doing fantastic. How are you?
I'm good. I love that I get to start my day with you. I feel like I'm on a science show right now. We're at Internet of Things. What is Internet of Things, and what's new and exciting this week at Sapphire?
Okay, well, the internet has gone through several waves. The first wave was about getting access to data and making sense of it. And indeed, that's Google's mission from day one, was to organize the world's content and make it available to everyone. Second wave was making people connected to other people. That was social networking. This is about connecting people to things, like this tractor.
Okay, so when we talk about connecting people and things, why is this important? Why should companies care and start to learn about this machine-to-machine Internet of Things phenomenon?
So there are two main reasons. One main reason is that they get better control of their assets in the field and can react more quickly if there's a problem. And the second reason is that it can open up new revenue streams. For example, the manufacturer of this piece of equipment can offer a premium service plan whereby they monitor the equipment for any potential problems and then alert the owner before the owner is even aware that there's a situation.
So we're solving, it sounds like, business problems. What are the pain points that we're addressing?
The pain points are that we've got these very expensive assets out in the field, and if they go down, the operation stops. It's done. This is meant to represent a mine operation, and if you're not able to excavate the materials, then you can't continue your work. And being able to proactively identify a problem and then deal with it before the whole machine goes down means operations can stay functional.
Interesting. Well, I know we talk a lot about it, but I want to get my hands on this. Let's play with this stuff.
Sure. Okay, I have two things for you to see today. One is a model of a Sandvik mining equipment, and this machine basically makes small rocks from big rocks, and then it excavates them on that conveyor belt. And what I've done is taken a piece of this loader off to give you a sense of how we can enable remote monitoring of high dollar assets like this mining equipment. And what I've done is I've wired a temperature probe to this. Now obviously this is a prototype setup, but in real life this could be a long-range battery-assisted RFID sensor, it could be Wi-Fi, it could be any number of things, and it could be uploaded via cellular backhaul, and what we can do is create applications that monitor the condition of these assets and alert us to the problem. So let's take a look at what that might be. What I have here is an application, we're calling it Blue Sky Mining. This is just a fictitious application, but it is relevant to anybody who had similar operations in real life. And here, as an operator of this equipment, I can zoom in, see all of the equipment in my region where I manage, and then drill into one of these and get some data. And what it's doing is it's loading a 3D image of this piece of equipment that I can spin around and manipulate. And what I'm going to do now is start the temperature capture. And what's going on is it's receiving information from this probe. Now, at some point, what could happen is that the piston can overheat, and we have defined triggers for taking corrective action when that occurs. One of the triggers is the difference between the ambient temperature, which is shown here, and the temperature of the control. And the reason this is important is because mines are hot places. We don't want to send somebody down there to fix the equipment just because it's hot. We want to make sure that there's actually a problem. And you can see here, if you want to hold this temperature probe, you can see the temperature will rise. Yes, she has warm hands. So what we can do here is you can see this flashing icon, and I can drill in, and I can create a notification for somebody to go in and fix the problem. Return. And this has created a work order. And so you can see, oh. Okay. What this has done is it's going to create a work order, and it's going to automatically assign it to somebody who has the right parts and the right expertise to address this condition. And I'm going to create that so it's uploaded to the system. And you can see here, not only do I have an overview, but I can get detailed information about exactly what's going on. We already did that, so we'll just take a look at this, and you can see here a blow up of exactly the part we have in front of us. And the last thing I can do is I can go into predictive maintenance and look at the trend over time, because what we're concerned about is that this particular asset either overheats relative to the ambient temperature, perhaps the temperature climbs faster than we're expecting it to, and we can create a statistical model to fix that, or it just exceeds a certain threshold, and that's what's happened here with this alert. And here I can see all of the alerts for a particular piece of equipment. So again, the idea behind this application is that I can proactively monitor the assets that I've deployed in the field without being there myself and take action before the asset goes down.
Benjamin, as always, I have learned a lot. I hope we have the opportunity to do this again, but in the meantime, best of luck for the rest of the show and in 2013.
Thank you for having me.